Hello guys, today we are going to talk about normalization forms in database management system. What is normalization? Simply, normalization is organizing the data in the database. And normalization is a systematic approach of decomposing tables to eliminate data redundancy and undesirable characteristics like insertion, update, and deletion. And there are some rules of normalization. Here you can see first, second, third, fourth, normal forms, and BCNF. First normal form. What is first normal form? Here you can see there are some rules about first normal form. Firstly, it should only have single atomic valued attributes, and values stored in a column should be of the same domain. And all the columns in a table should have unique names, and the order in which data is stored doesn't matter. Here we can see student table, and there are three columns called roll number, name, and subject. This table follows three rules of first normal form, but besides this one, because here we can see O, S, and C and values in one row in this column, and also here C and C++ subject in subject column. This is the problem. In order to solve the problem, we can create another table which defines first normal form. Here you can see operating system and computer network C and C++ subjects separately in different rows. In order to form first normal form, we should write these values singly, separately. And second normal form. There are also some rules of second normal form. Firstly, the table should be in the first normal form, and there should be no partial dependency. What is partial dependency and what is dependency? Dependency is the primary key here, student ID, and the other non-primary keys, which mean other columns, depends to this column. With the help of student ID, by using these values, we can find all information along the table. And what about partial dependency? Partial dependency also has different columns, and here you can see score ID, student ID, subject ID, marks, and teacher columns. And here student ID and subject ID should be a primary key together. With the help of these primary keys, two columns, we can find other information along the table. But here we can see teacher column. Teacher column, the values depends on only to the subject ID. There is no job to the student ID, but student ID and subject ID together are primary keys. So here is problem. How to remove partial dependency? In order to remove partial dependency in the table, we use extracting. Here you can see subject table. In the above, there is teacher column here. In order to extract the table, we should move teacher table into the new table, and here we can use subject ID and subject name in order to make primary key together. And this is option. And here third normal form. There are also some rules in the third normal form. Firstly, it should be the second normal form, and it should not have transitive dependency. What is transitive dependency? when a non-prime attribute depends on other non-prime attributes rather than depending upon the prime attributes or primary key, it is transitive dependency. More clearly, here we can see exam name and total marks, which added to our score table in the previous slides. We can see it says more data now. And primary key for our score table is a composite key, which means it's made up of two attributes or columns called student ID and subject ID. Our new column, exam name, depends on both student ID and subject ID. For example, a mechanical engineering student will have workshop exam, but a computer science student won't. And for some subjects you have practical exams and for some you don't. So we can say that exam name is dependent on both student ID and subject ID. And what about our second column, total marks? And does it depend on our score table's primary key? Well, the column total marks depends on exam name. As with exam type, the total score changes. For example, practicals are of less marks while theory exams are of more marks. But exam name is just another column in this table, not primary key or even a part of primary key. This is transitive dependency, and this is the problem in the table. And how to remove transitive dependency? By using decomposition, by extracting tables, we can solve the problem easily. Take out columns exam name and total marks here, exam name and total marks from score table and putting them in a new table and using exam ID wherever required in the case. And here our original table with exam ID. Exam ID is foreign key here, which connects two tables together. And here Boyce-Codd normal form, which means BCNF. BCNF also has some rules. Firstly, it should be in the third normal form, and for any dependency A defines B, A should be a super key. In simple words, it means that for a dependency A defines B, A cannot be a non-prime attribute if B is a prime attribute. Below, we have a college enrollment table with the columns student ID, subject, and professor. As you can see, we have also added some sample data in the table. In the table here, one student can enroll for multiple subjects. For example, student with student ID 101 has opted for subjects Java and C++. For each subject, a professor is assigned to the student, and there can be multiple professors teaching one subject, like we have for Java here, P Java professor and P Java 2 professor to Java subject. And what do you think should be the primary key? Well, in the table above, student ID and subject together form the primary key, because using student ID and subject we can find all the columns of the table. One more important point to note here is one professor teaches only one subject, but one subject may have two different professors, as we said before. Hence, there is a dependency between subject and professor here, where subject depends on the professor name. This table satisfies first normal form because all the values are atomic, column names are unique, and all the values stored in a particular column are of the same domain. And this table also satisfies the second normal form, as there is no partial dependency and there is no transitive dependency. Hence, the table also satisfies the third normal form. But this table is not Boyce-Codd normal form. Okay, how to satisfy BCNF? Before this, why this table is not in BCNF? In the table above, student ID and subject form primary key, which means subject column is a prime attribute, but there is one more dependency. Professor depends to the subject column. And while subject is a prime attribute, professor is non-prime attribute, which is not allowed by BCNF. Okay, how to satisfy BCNF? To make this relation table satisfy BCNF, we will decompose this table into two tables, like student table and professor table. And this relation satisfies both Boyce-Codd normal form, because by using professor ID we can find professors and also we can find subject. Fourth normal form. Also, it has some rules. Firstly, it should be in the Boyce-Codd normal form, and the table shouldn't have any multi-valued dependency. Okay, what is multi-valued dependency? Okay, a table is said to have multi-valued dependency if the conditions, for example, for a dependency A defines B, if for a single value of A multiple value of B exists, then the table may have multiple valued dependency. And also a table should have at least 3 columns for it to have a multi-valued dependency. And for a relation A, B, C, if there is a multi-valued dependency between A and B, then B and C shouldn't be independent of each other. Okay, in the example. Okay, here you can see college enrollment table. Here SID, course and hobby columns. As you can see in the table, student with SID 1 has opted for 2 courses. Student with science and math and has 2 hobbies, cricket and hockey. You must be thinking what problems this can lead to, right? Well, the 2 records for student with SID 1 will give rise to more records as shown below, because for one student 2 hobbies exists, hence along with both the courses these hobbies should be specified. Here you can see 4 ones which made multi-valued values. And how to satisfy fourth normal form. Here we can see course table and hobby table. In order to make the above relation satisfy the fourth normal form, we can decompose table into 2 tables. And by using SID and course column, we can define student IDs and their courses, and by using their IDs, we can also define their hobbies. Overall, normalization is used for mainly 2 purposes. First, eliminating redundant useless data and ensuring that the dependencies make sense, data is logically stored. This is the end of the video. Thanks for watching. See you then.